Hello everyone, I welcome you all to Prime Mathematics. So today we are going to discuss JEE Advanced 2025 paper number 2, question number 12, right? So let's first read out the question, what's given in this question. So here it is mentioned we have the vector x vector, y vector and z vector which are used under the linear combinations The first vector is the linear combination of alpha, beta, and -1 to obtain the capital X vector. And in the second, we have alpha, beta, -1 as the combination to obtain capital Y vector. And similarly, we have Z vector as alpha, beta, -1, right? So if we know that these vector like capital X vector, Y vector, Z vector all lie in the same plane, in a plane, then we know that the scalar triplet product of capital X vector, capital Y vector, capital Z vector is equals to 0. Now, since they are already in the linear combination of the vectors X vector, Y vector, Z vector, then by using the determinant property, if we separate the combinations, right? Separate the coefficients of the x vector, y vector, z vector for each vector like capital X vector, y vector and z vector, we can evaluate the triplet product. So it will be first for capital X vector, we have coefficient as alpha, beta and -1. Similarly, for coefficient for y, we have x coefficient as -1, y coefficient as alpha, z coefficient as beta. For capital Z vector, we have coefficient of x as beta, coefficient of y as -1, coefficient of z as alpha, right? Now we need to find the triplet product for xyz. So simply it will be the determinant of 1, 2, 3, coefficient of ijk in x and coefficient of ijk in y, we have 2, 3, 1, right? Then in this z vector, we have 3, 1, 2, which evaluates to 0. Now clearly one can observe this will be some kind of like a scalar, and scalar which is a non-zero, so we can get this as 0. And you can clearly observe the determinant also, if you wish, that will be also a non-zero. If we wish, we can calculate by just expanding, so I think there is no need. So this will goes to 0. Now we just need to find simply the determinant of alpha beta -1 -1 alpha beta, beta -1 alpha. Now using the determinant property, what property? If we use R1 tends to R1 plus alpha times of R2 and R3 tends to R3 plus beta times of R2, what we obtain? First we obtain 0 over here, then we have beta plus alpha square, then we have alpha beta -1. Similarly, in the third row we obtain 0, then next we have alpha beta -1, then beta square plus alpha, right? Now expansion along C1, expand along C1, what we get? It will be negative, negative, positive, right? So determinant will be across, like it will be beta plus alpha square. Okay, so it will be beta square plus alpha square multiply with beta square plus alpha, and in the next we have alpha beta -1, right? Minus alpha beta -1 whole square. This will be the determinant which you will obtain, and this will goes to 0. Now if we just put this over to the RHS section, we get, and simplifying this, we get beta cube plus beta alpha plus alpha beta whole square plus alpha cube, and transferring this over to the RHS and expanding the a minus b whole square formula, we get alpha square beta square plus 1 minus 2 alpha beta. Clearly alpha square beta square just gets cancelled out. So what we obtain alpha cube plus beta cube and 3 alpha beta and minus 1, which will be equal to 0. Now what we can do, we can do a use of an identity. What identity we know? We know that x cube plus y cube plus z cube is equals to 3xyz if and only if x plus y plus z is equals to 0, right? So if we try to construct over here, like this is alpha cube, this is beta cube, and minus 1 is nothing but minus 1 cube, and transferring this over to the RHS section, we get minus 3 alpha beta, and one can simply write as 3 multiply with alpha multiply with beta multiply with minus 1. Now clearly we can see this is your x cube, this is your y cube, this is your z cube, this is 3xyz. So of course it is following this criteria which we use like the algebraic identity. Then one can clearly say that alpha plus beta minus 1 means x plus y plus z will be nothing but it's 0. So one can say alpha plus beta is equals to 1. Now using this condition over to the section, we get alpha plus beta is 1 minus 3, which will be minus 2. I hope it is clear. If you have any query, please comment in the comment box.